Next, we are given here with a binomial expression, and we are to evaluate the Laplace transform of negative 2 plus e to the power of 4t. We are going to use here the linearity property. So the linearity property, which would allow us to do it like this. So the Laplace transform of negative 2 plus e to the power of 4t, this could be written as the Laplace transform of negative 2 plus the Laplace transform of e to the power of 4t. With this linearity property, we don't need to use the actual definition for the Laplace transform of a certain function of t, which is actually the integral from 0 to infinity of e to the power of negative st, your f of t dt, or your f of t is actually equivalent to negative 2 plus e to the power of 4t. We're doing this linearity property because we do have rules for constant and for an exponentiation. We have the rule for the Laplace transform of 1 is equivalent to 1 over s. We also have the rule for our e to the power of t, which is identified as 1 over s minus 1. But in this case, since our t has a numerical coefficient other than 1, the rule for the exponential function with alpha t as alpha any constant is actually identified as 1 over s minus the given alpha. So with this now, we can actually factor out here, according to the linearity property, you have negative 2, the Laplace transform of 1. Still, you will have here the Laplace transform of e to the power of 4t. Okay? Where our first is negative 2 plus the Laplace transform of 1 is this. So you have 1 over s, so the product of that, plus the Laplace transform of our e to the power of 4t, where our alpha is actually equivalent to positive 4. It's positive 4. So the result for this is actually equivalent to, you have here 1, or you don't need parentheses for that, 1 over s minus 4. Okay, this is the Laplace transform for our given function here for e to the power of 4t. So with this now, combining or multiplying the first terms, you have here negative 2 over s, you have here plus 1 over s minus 4. This is the Laplace transform of the binomial expression negative 2 plus e to the power of 4t. Now, without using this, but only those rules we have already previously illustrated in some of the videos. Now, if you would like to use this, of course, you may. As long as you use the proper notation for your function, you can break that into two portions, and basically you will get here. Now, some references would advise us to add this notation that s is actually greater than 4, so that this function here will not be equivalent to 0, because you would like it to converge as t approaches to infinity in our Laplace transform. So it's also true for this. Don't worry about that because it's already greater than 4. But just to be consistent with what we did previously, when we talk about simply the Laplace transform, let's remove this and stick with the result at hand. Thank you very much for watching.